Okay, so this is for problem 21 on the study guide page when it refers to the area under the graph. That's a very unfamiliar term for a lot of you because if you haven't talked about it in math, you have no idea what they're talking about. So what I've done is I've drawn a picture to sort of help you get the idea, and we're going to go over it. So on question 21, it shows a picture of the graph on the top of the page. And this is my lovely drawing of it right here. So you can see the 45 through 5 on the side there, and then the distances measured down here. And what the area under the graph is referring to is just the stuff down here. So basically what you're going to be doing is using math area formulas to find out how much work has been done. So in problem 21 specifically, we're splitting the graph up into 3 different parts like this. So we have the first rectangle here, then we have our second rectangle, and the triangle up here. So we're going to be finding the area of each of them individually. So for a rectangle, we know that our area formula is length times width. So we take the length times the width. So you have 0.5 meters down here at the bottom and 30 newtons at the top, and you multiply those together. Then you do the same for the second rectangle. And we get up to the triangle, and that's when things change a little bit because you're doing base times height. Okay, so when you're looking at this graph, you have the triangle's base, which is right there at the bottom. And like I said, that's going to be a distance of 0.2 because you're only going from 0.5 to 0.7, and the height. And it's going from 30 to 40 newtons, so that's going to be 10 newtons. So 1/2 base times the height, 0.2 times 10, and that should help you solve that problem. It's just breaking it up in a different way to find the work, and I hope to go over the math a little more with you when I get back.